Mind your decisions, I'm Presh Talwalkar. ABCD is a square with a side length equal to 1. Pick point E alongside DC and pick point F alongside BC such that EAF is a 45-degree angle and AFB is a 70-degree angle. The first part of the question is to solve for the measure of angle AEF. The second part of the question is to solve for the perimeter of triangle ECF. That is, solve for EC plus CF plus FE. A version of this problem was given to 9th grade students in India who had only learned geometry. Therefore, the challenge is to solve without using trigonometry. Pause if you'd like to give this problem a try, and when you're ready, keep watching to learn how to solve this problem. We will solve the problem by thinking outside the box. I give credit to the solution to Anand Gautam, who emailed it to me. Now let's get started. First, consider triangle ABF. Since angle B is a 90-degree angle, angle FAB must be equal to 20 degrees. Then consider triangle ADE. Since angle A is a 90-degree angle, angle DAE must be equal to 25 degrees. Then, since angle D is a 90-degree angle, angle AED must be equal to 65 degrees. Now let's go back to triangle ABF. The trick to this problem will be to think outside the box. We will rotate this triangle 90 degrees clockwise about vertex A. We've created a congruent triangle, and we'll label this vertex as F' because it is the image of the vertex F. From here, we have F'AD is equal to 20 degrees by construction. We then will solve that angle F'AE will be equal to 20 degrees plus 25 degrees, which is equal to a total of 45 degrees. Now we are going to consider that AF' is equal to AF by construction. We thus have two triangles that are congruent by side angle side. Here we have one side that's equal to itself. Then we have two angles that are equal to 45 degrees, and then we have two sides that are equal to each other. Therefore, these two triangles are congruent. In fact, they are mirror images of each other. This means angle AEF is exactly equal to angle AEF', and so it is equal to 65 degrees. And we're done with the first part of the question. Now, let's solve for the second part of the question. What is the perimeter of triangle ECF? Let's consider a numerical approach. Imagine that we have a ruler and that we can measure the length of EC. Suppose we estimate it to be 0.6389. Let's do the same thing for the other sides of CF and FE. We end up that the sum of these three lengths will be equal to 2. Now, what would happen if we change the points E and F? A remarkable thing happens. No matter where we pick the points of E and F, the perimeter of this triangle will always be equal to 2 exactly. This is good enough for a numerical approach, but why does it happen mathematically? Let's prove this. So we go back to our original diagram. Construct triangle AF'D. Recall that triangle AF'E is congruent to triangle AFE. Let's label some lengths. First, suppose that BF has a length equal to x. This means DF' also has a length equal to x. Now, FC must have a length equal to 1 minus x because the entire side BC has a length equal to 1. Next, suppose that DE has a length equal to y. We must have that F'E, which has a length of x plus y, will have the same length as EF. Therefore, EF has a length equal to x plus y. Finally, EC will have a length equal to 1 minus y because the entire side DC has a length equal to 1. Now let's consider the perimeter of triangle ECF. It'll be equal to 1 minus y plus 1 minus x plus y. We can cancel out the y's and cancel out the x's, and we're left with 1 plus 1, and that's exactly equal to 2, which is what we saw in the numerical approach. Amazing! Thanks for making Mind Your Decisions one of the best channels on YouTube. As always, thanks for watching, and thanks for your support.